Hi students, welcome to MI Academy, and today in this video we are going to continue the grade 10 chapter 2, of the science, motion in straight line. Until now we have studied distance, displacement, speed, and velocity, and acceleration and deceleration. Today in this video we will study about displacement time graphs, velocity time graphs, and gravitational acceleration. If you have not still subscribed to MI Academy, then click the subscribe button, and turn on the notification bell icon, to all, so that you can watch my upcoming videos without missing. Graphs that illustrate how the displacement of a body varies with time are known as displacement time graphs. These graphs are plotted by marking the time on the x-axis and the displacement on the y-axis. And remember students, always when you label the axis you have to name the symbol and the unit. The gradient of a straight line can be calculated by dividing the difference between the y-coordinates of any 2 points on that line, by the difference between the corresponding x-coordinates of the 2 points. Since the x-axis represents time, the difference between the x-coordinates of 2 points is a time interval. The corresponding difference between the y-coordinates is the displacement of the body during that time interval. What we get when the displacement is divided by time is a velocity. So now let's look at an example. The following table shows the variation of the displacement of a body with time. The displacement of the object is given with time, so if we draw the graph this is going to be like this. Then what is the gradient here? It is the velocity. So let's take 2 points of y-coordinates and x-coordinates and find the gradient. BC divide by AC, that is 15 minus 3, divide by 5 minus 1, that is 12 meters, divide by 4 seconds, so the gradient, velocity is 3 meters per second. Therefore, the velocity of the motion represented by the above graph is 3 meters per second. So remember students, at the same time by looking at the shape of the graph you can come to this conclusion. A straight line going through the point of origin indicates that the object traveled with uniform or constant velocity. I hope you have understood how to draw displacement time graphs. Now we will discuss velocity time graphs. In order to represent the variation of velocity with time, velocity time graphs are used. In velocity time graphs, the time is plotted on the x-axis while the velocity is plotted on the y-axis. On x-axis you have to write the symbol t and the unit seconds within brackets, and on the y-axis we have velocity, so you will have to name the axis velocity and the symbol will be written as v. And the unit will be meter per second. As mentioned before, the gradient of the straight line can be obtained by dividing the difference between the y-coordinates of any 2 points on the graph, by the difference between the corresponding x-coordinates. In this graph also, the x-axis represents time. Therefore, the difference between x-coordinates gives a time interval. The corresponding difference in the y-coordinates gives the velocity difference during this time interval. Velocity difference divided by time gives an acceleration. Therefore the gradient of velocity time graph is acceleration. And if we want to find the displacement in velocity time graph, we have to calculate the area of the shape of the graph in the velocity time graph. Therefore the displacement is equal to the area under the velocity time graph. Let's look at an example, and do some calculations for your further understanding. The table below gives the variation of velocity with time for the motion of an object. So if we draw the graph this is going to be like this. Then what is the gradient here? It is the acceleration, so let's take 2 points of y-coordinates and x-coordinates and find the gradient. 18 minus 0, divide by 6. That is 12 meters, is 3 ms minus 2. Therefore, the acceleration of the motion represented by the above graph is 3 meters per second. So now we have to find the displacement, so displacement is equal to the area under the velocity time graph. Then here it's a triangle shape, so the area of the triangle can be calculated as half into base into height, so the base in here is 6, and the height is 18. Then half into 6 into 18 is 54 meters. This graph is a straight line, because the increase in the velocity during each 1 second interval is the same. This represents a motion with a uniform acceleration. Now let's look at another example. This is a velocity, Time graph for the motion of a body moving at a constant velocity of 6 meters per second, so now we have to find the displacement. So displacement is equal to the area under the velocity, time graph. Then here it's a rectangle shape, so the area of the rectangle can be calculated as base into height. So the base in here is 8, and the height is 6, then 8 into 6 is 48 meters. Now let's do another question. An object starting from rest acquires a velocity of 15 meters per second, after moving for 6 seconds under a uniform acceleration. Then the object moves with that velocity for 6 seconds and comes to rest after decelerating for 3 seconds. First question is plot the velocity, time graph for this motion. First plot the points 15 and 6, then they have given a uniform acceleration, so it's a straight line moving from 0 to 15 in 6 seconds, then the object is moving with constant velocity for another 6 seconds. So from that point you have to drag the line parallel to the x-axis until 12 seconds, then the object has come to rest after decelerating for 3 seconds. So now you have to bring the straight line to 0 at 15 seconds. Finally you will get a shape like this. Then the next question is find the acceleration during the first 6 seconds. So the acceleration during the first 6 seconds is the gradient of the OA part of the graph, that is 15 meters per second divided by 6 seconds, that is 2.5 ms minus 2. Then the next question is what is the displacement during these 6 seconds. So we know that displacement is equal to the area under the velocity, time graph, so here the displacement during the first 6 seconds is area of the graph below OA part, that is half into 15 into 6. That is 45 meters. Then the next question is what is the distance traveled under the uniform velocity? We know that the object has traveled with a constant velocity during 6 seconds to 12 seconds, so that we need to calculate the distance or displacement of that part. So distance traveled at uniform speed is the area of the graph below OB, that is 15 into 6, 90 meters. Then the next question is what is the deceleration during the last 3 seconds? Deceleration is the negative of acceleration, so acceleration during the last 3 seconds is 0 minus 15 divided by 3, that is minus 5 ms minus 2, therefore deceleration is 5 ms minus 2. Then the next question is what is the distance traversed during the last 3 seconds? Distance traversed during the last 3 seconds is the area of the graph below BC, so half into 3 into 15, that is 22.5 meters. Then the next question is write down an expression in order to find the total distance traveled by the object during the complete motion, using the velocity, time graph. Here you have to write an expression for the complete motion of the object, so you can see this is a trapezium shape, so the area of the trapezium shape is the half into sum of parallel sides into height. So you have to write that equation here. Then the next question is find the total distance traveled using the above expression. Half into 6 plus 15 into 15, that is 157.5 meters. So that's all. I hope you have understood how to draw velocity time graphs. Now we will discuss about gravitational acceleration. By experience we know that when a body falls, its velocity increases gradually. That is, the body accelerates. In order to give rise to an acceleration, a force must act on the body. The force that acts on a falling body is the gravitational force exerted by the Earth. The acceleration caused by the Earth's gravitational attraction is known as the gravitational acceleration. Its symbol is g. The average value for the gravitational acceleration at sea level is about 9.8 ms-2, but we consider as 10 ms-2 for your convenience in calculations. This means that the velocity of a free-falling body increases by the velocity of 10 ms-1 every second. When a body is moving vertically upwards, the velocity decreases by velocity of 10 ms-1 every second. Let's look at an example, and do some calculations for your further understanding. An object was projected vertically upward at a velocity of 30 ms-1, so here the initial velocity is 30 ms-1. As the velocity decreases by velocity of 10 ms-1 every second for a body moving vertically upwards, we have to decrease 10 ms-1 for each 1 second here, until it becomes 0 ms-1, therefore it will appear as follows: for 0 second it will be 30 ms-1, for 1 second it will be 20 ms-1, For 2 seconds it will be 10 ms minus 1. For 3 seconds it will be 0 ms minus 1. Now let's plot a graph for this. Then what is the maximum height of the object? Maximum distance reached by the object is the area under the graph. That is half into 3 into 30, that is 45 meters. Let's look at an example, where a fruit in a tree takes 4 seconds to fall to the ground. So we know that the velocity of a free-falling body increases by the velocity of 10 ms minus 1 every second. So here we have to increase the velocity of the object by 10 ms minus 1 until it reaches 4 seconds. Therefore it will appear as follows: for 4 seconds it will be 0 ms minus 1, for 3 seconds it will be 10 ms minus 1, for 2 seconds it will be 20 ms minus 1, for 1 second it will be 30 ms minus 1, for 0 second it will be 40 ms minus 1. Then now let's plot a graph for this. Then the velocity when it reaches the ground is 40 ms minus 1. Then what is the maximum height of the object? Maximum distance reached by the object is the area under the graph. That is half into 4 into 40, that is 80 meters. So now we have covered the chapter 2, and we have come to the end of our video, so please give a support to us by subscribing to MI Academy, and also please, like my videos, and add up your questions and doubts in the comments. I will try to reply them as soon as possible. Share the videos with your friends, and help them to learn quickly and easily.